There's a bit of a
So, as promised earlier, we were discussing techniques to solve quadratic equations, but now, the one that actually really works in every single situation is completing the square. But hopefully, you agree that it's a slightly a long process. So, if we can kind of summarize that process into a nice little package, that would be nice. For example, imagine that you want to have a computer solve the equation for you. So you want to do a little program that the computer will give you the equation and spit out the answer, right? So to program the completing square method, it may be a little bit of a pain. If we have a nice little formula, you just plug it in, calculate it, and then give back the answer, okay? So let's try to see if we can come up with such a thing. As you all know, such a formula exists, but let's actually prove it, okay? For example, do you believe it? Do you trust it 100%? How do you know that the formula that you learned earlier, it actually works? Okay? So that's why we need to prove things. Also, where did that formula come from to begin with? It was not somebody woke up and say, oh, by the way, this is how you solve a quadratic equation, this is the formula. It doesn't work like that. Okay? So the ideas that we have built up to now will lead us to actually come up with such a thing. So what's the goal here? So the goal is to solve an equation of the form a squared plus bx plus c equals 0, where a is different than 0. Okay? Because of course, if a is equal to 0, then this term is not here, the quadratic term is not there, and this is just a little linear equation, right? We know how to solve it. So we want to solve an equation like this in general. And what we're going to do is, the idea is that we're going to solve this equation, but with the coefficients a, b, and c, with our specific numbers. And the only thing that we have at our disposal that we know always work is completing the square. Okay? So let's do it. So idea, complete the square. All right, so we have ax squared plus bx plus c equals 0. Okay? So if we want to complete the square, what's the first thing that we need to do?
take half of b squared.
Before we do all of that, there is some preparation that we need to do, right? What do we need to do?
Move c to the other
We
side.
need to get rid of this guy, right? We cannot have a number in here. We don't know what a is. If it's 1, we're good, but what if a is not 1? So the first thing, we need to get rid of it. How do we get rid of this? We divide everything by a. So to activate this completing the square process, we have to divide the entire equation by the leading coefficient. So we have b over ax plus c over a equals 0. Okay? Next, this number, c over a, whatever that is, we move it to the other side, right? It will be negative c over a. And now we complete the square, so we need to figure out what to put in this space so that it becomes a perfect square. So what goes in there? What do we need to do? You look at the coefficient, right? And what do we do to it?
Divided by 2.
Divided by 2 and square. So we look at b over a, and then divided by 2, and we square. What is that? So this would be, remember, what's b over a divided by 2, by the way?
B over 2a.
B over 2a. Good. Does everybody remember how to divide fractions? So let me just do a little side thing here. So if you want to do b over a divided by 2, remember, this is like saying 2 over 1. So the way you divide fractions is you turn into a product, but you have to flip the second one. Okay? So it's b over a times 1 over 2. That's how you divide fractions. And then that's b over 2a. Okay? So that will be b over 2a squared. What is this equal to? What is this?
B squared over 4a squared.
Over 4a squared. Okay? So that's what we need. So that's the quantity that we need to have in here. So we add it to both sides. So b squared over 4a squared plus b squared over 4a squared. Okay? All right. So now what's the next step? We factor the left-hand side. How does the left-hand side factors? What is this?
X plus b over 2a squared.
Very good. Remember, this is x plus b over 2a, right? So this is automatic. So what goes in here? Exactly this quantity, the one that we had before we took the square. So x plus b over 2a squared equals to, now I'm going to combine the right hand side. Let's see, let me rewrite it like this, minus c over a. Now, let's see, we talked about last time how to find these common denominators when we have variables. So what's the LCD here? What's the LCD? I explained to you how to do this last time. So let's see. You need to factor each denominator, right? So the first one is 4a squared. How do we factor this completely? 2a squared times a squared, right? Prime factorization. And then a, well, a is a, right? A is a. So to find the LCD, what do? Write down all the prime factors that you see. So I see a 2, I write it. I see an a, I write it. Then come back and fix the powers. You need to write the highest power that you see. I see a 2 squared, so I need to have a square here. I see an a squared, so I need to have an a squared here. In other words, the LCD here is 4a squared, which you could say from here, right? Because this can be divided by a. So this guy is the LCD. But that's the general procedure. Okay, so that means, if I want to combine this, I need to have a 4a squared down here. So what are we missing? We get a 4a squared. 4a. We need a 4 and we need an extra a, right? So I multiply this by 4a, but I also need to multiply the top by 4a. Okay? So this becomes x plus b over 2a squared equals, now it will be b squared minus 4ac over 4a squared. So this right here, this should start to look familiar. If you already know the formula, this should look already familiar to you. And then to solve, what do? We take square root, right? Now remember, plus or minus the square root of this quantity. So we get this. Simplify, so you get plus or minus square root of b squared minus 4ac over 2a. Because the square root of 4a squared is 2a. And then finally, what do we have here? So then move it to the other side. So we get negative b over 2a plus or minus this quantity. And then because the denominators are the same, we combine. So negative b plus or minus square root of b squared minus 4ac all over 2a. Okay? And this right here is what you normally know as the quadratic formula. And notice that in here, all you really need to know is what's A, B, and C. Plug it in, and then you get your answer. Understand that there are two solutions here in general, one with the plus, another one with the minus. Okay? We're going to see that there are situations in which you may get only one solution, and that is when this term becomes 0, right? If this term equals 0, it could be 0, then you would only have one solution, namely negative b over 2a. In that case, we say the solution is double, or with multiplicity 2. Okay? Will be more clear once we talk about polynomials, this idea of multiplicity. Okay, questions about this formula? So what I want you to understand is that this is really just completing the square. Okay? It's just that we did it in general. It's easier before because we have complete numbers. Here we don't, so we have to work with A, B, and C. Okay? But the good thing about it is that this allows us to obtain a formula. So what we just did is the proof of the following theorem. That's the quadratic formula. And the statement is that the equation a squared plus bx plus c equals 0 with a, b, c real numbers and a different than 0. So this equation has solutions x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Okay? So now, if, for example, if I ask you to solve a quadratic equation and I don't specify anything else, you can do it however you want. Factoring, quadratic formulas, complete the square, whatever is your favorite way of solving the equation. Unless I specifically tell you solve this by factoring or solve this by completing the square, because I want to know if you can do it that way. Okay? But if it's just about solving, you do it however you want. Questions? Okay, so let's see. Does everybody know the quadratic formula already? Okay, so if you don't, it is a good formula to memorize. But also, if you are not comfortable memorizing things, remember that there are alternatives. Okay, that's why we talked about the previous technique. All right, so let's do examples. So solve using the quadratic formula. Okay, let's do 2x squared plus 3x plus 5 equals 0. Let's do x squared minus 5x plus 1 equals to 0. 2x minus 5 equals 3 squared. And then lastly, let's do 25x squared plus 20x plus 4. And then once we observe the solutions that we get here, let's make a little observation. But first, let's practice. So I'm going to do number 1, and then I'm going to let you try the other 3. Okay? So solution. So let's do the first one. So we have 2x squared plus 3x plus 5 equals 0. So the first thing that you need to do, if you want to use a formula, first of all, make sure it's a quadratic equation. Second, make sure that everything is set to one side and then 0 on the other side. That's the first thing. Okay? So in this case, we already have it equal to 0, so we don't have to worry. Next, you need to identify your A, B, and C. Now remember, when you write A, B, and C, you need to include the signs. If you see something negative, it has to spell that. Okay? All right, let's see. So here, what's A, what's B, and what is C? Yes?
A is 2, B is 3, C is 5.
And C is 5. Does everybody understand this? And now, just go straight to the formula. Now, we know that the formula is, let me write it here, x negative b plus or minus square root of b squared minus 4ac over 2a. So you can plug in here and then simplify, but I always like to compute this quantity first, and then later I'm going to make an observation about that quantity. Anyways, we need it. So this quantity, I'm going to calculate it here. And then whatever number I get, I put it there, and that way the formula doesn't look too messy. Okay, so that's going to be 3 squared minus 4 times 2 times 5. So what is this? So that's 9 minus 40. Yes, which is negative 31. Okay? So this quantity b squared minus 40c is giving me negative 31. And now we plug in. So negative b, so it will be negative 3 plus or minus square root of negative 31 over 2 times 2. Okay? And now simplify. So in this case, there's really not much to do. This square root of negative 31 is really square root of 31i. And all of these over 4. And when complex numbers show up, you need to write it in standard form. You have to write it in the form a plus bi. Okay? So we get negative 3 over 4 plus or minus square root of 31 over 4i. And those are the two solutions. Okay, questions? Did you understand this? Okay, so go ahead and try the others. I'm gonna give you about 5 minutes, and then we do it together. Okay, anybody has an answer for number 2?
5 plus or minus radical 21 over 2.
Very good. Everybody getting that? 5 plus or minus square root of 21 over 2. Yes? Okay, good. So let's see. Let's see. So it was x squared minus 5x plus 1. Okay, so first thing that we do is identify A, B, and C. What are they? -5 and 1. Good. Next, I'm going to calculate this quantity. Okay, b squared minus 40c, just to make it easier. So that will be -5 squared minus 4 times 1 times 1. So that's 25 minus 4, which is a 21, and now we are ready because the formula is, you can tell me a formula?
Negative b plus or minus the square root of b squared. Minus 4ac.
Square root of b squared over 4ac over 2a.
Over 2a. And now we just plug in a number. So negative b. So remember, here you have to be careful. So this negative is from the formula. Now, if b happens to be negative itself, then there will be negative, negative. Yes? Making it positive. So let me just write it down. So it'll be negative, negative 5 plus or minus square root 21 over 2 times 1. And now just simplify, and we get 5 plus or minus square root of 21 over 2. Good. Questions? All right. You know, it's nice. The only thing that I could say is, well, the problem is that you need to remember this. Okay? Make a little mistake, like forget the square here or the minus here or something, and then that's it. Right? So be careful. All right. So how about number 3? What was number 3? 2x minus 5 equals 3x squared. Anybody has an answer for this one? Yes?
I'm not confident about this in the slightest, but here is nothing. 1 plus or minus the square root of 14i over negative 3.
Square root of 14i over negative 3, like this?
Negative 3.
Or negative 3. Okay?
Yeah.
So, okay, so you need to give the answer in standard form. So if this is the answer, how would you write it?
Well, I guess I need to.
That should be negative 1 over 3.
Oh, complex standard form. Yeah, it will be negative
Right.
1 over 3 plus or minus square root of 14 over negative 3i.
Yeah, but then the negative, you could say minus plus, which is the same thing as plus or minus. So then it's just plus or minus square root of 14 3 over I. Yes, square root of 14 over 3 I. It will be like that. This is the answer. Now, are you guys getting the same thing? No? Okay. What is it? 2 square root of 14. Yeah. Like that? Like this? But
I mean, I got everything else.
with the 2 here. Okay, so it looks like there could be a 2 in here. Anybody else have something different?
I got negative 2 plus or minus the square root of negative 56, and then that's divided by negative 6.
The square root of negative 56.
Which would,
Yeah, but you have to simplify.
yeah, so 2, okay, so then 2 divided by,
Negative or minus.
2 divided by 6 plus or minus, 50, the square root of 56 divided by negative 6i. Well, plus or minus goes for them.
Like that. Is- Like that. Negative 2 plus or minus square root of 56i over 6. And then split it.
Yeah.
Okay. Is everybody getting the same thing?
No.
No? Okay. Okay, so it's interesting. A bunch of different responses. What do you get?
I got 1/3 plus or minus radical 14 over 3i.
Okay, so this is kind of close to this one. It's just
Yeah,
a,
I think that.
it's a negative.
I think that second was more accurate. I just looked over my answers and I completely forgot a minus at one point.
So let's see. None of these issues seem to happen when we're doing the previous exercises with the other techniques, right? So I stress it. Be careful because it seems like the use of quadratic formula, may not be a good idea in general. Be careful. You miss a sign, that's it, right? You get the problem wrong, that's it. So keep that in mind. Anyways, we're doing these 2 practice. So here is an advice. You can always make it so that your A is positive, okay? Instead of moving the 3x squared over here, what I'm going to do is I'm going to move these 2 guys to the other side. I like the A to be positive, okay? It doesn't matter, but I don't want to have a negative down here, then I have to deal with that and so on. So let's just make sure, I will just make sure that A is always positive. So I'm going to have my 0 here. And then I'm going to bring everything to the right hand side, okay? It doesn't matter, 0 equals to this, the same thing as this equals to 0. All right, so now with this, what are A, B, and C? What are A, B, and C?
A is 3,
3,
B is -2,
-2,
and C is 5.
and C is 5. Okay, next, let's compute B squared minus 4AC. And that's just so I don't have a mess in my formula, and then you have to be writing a big stuff. So let's see, -2 squared minus 4 times 3 times 5. So what is this? So this is 4 minus 20 times 3, that is 60.
-56.
So we get, yeah, I was gonna write 54. So we get -56. Catch me on time. So then the solution will be negative b plus or minus. I'm repeating the formula just to ingrain it in our brain. Okay, so it will be minus minus 2, so that's just a positive 2, plus or minus square root of -56 over 2 times 3, namely 2 plus or minus. So let's see, 56. What can we do with 56?
It's 4 and
So it will be divided by 4, you get 14, right? It's 4 times 14, so comes out as 2. So it will be 2 square root of 14i
all over 6.
over 6. And then we can factor out 2 here, or if you want, we can just already split because of the complex number thing, and then we simplify individually. But if we didn't have the I, okay, if we didn't have the I, don't leave your answer like this. Factor out the 2 and then cancel it with the 6. So you have the 3 in the bottom, okay? All right, so here I'm going to do 2 over 6 plus or minus 2 over the square, 2 square root of 14 over 6i. But then these things cancel. And then we get 1 over 3 plus or minus a square root of 14 over 3i.
Yep.
Okay. Questions? Are you okay with this?
Yes.
So, I think that most of the issues were in the simplifying part, not really in the throwing into the formula, but really when you're simplifying, you have to be careful, okay? And yeah. And for example, here on the standard, this negative is gone because, well, it really depends what your A, B, and C were. Yes. Yeah. But at the end of the day, you have to get the same answers. So then, if you have a negative here, then you should have had a negative down here as well. So then they will cancel each other and so on. Okay, good. Let's see, we have was 3. Okay, one more to go. So 25x squared plus 20x plus 4. So, okay. That was 25x squared, forgot, plus 20x plus 4. Okay, so this one, it could be done also by factoring, by the way, but let's do it using the formula, okay? So let's see, you should be fine already identifying A, B, and C, so typically we don't actually write that down. That's already implicit in here. So I'm gonna go straight to what I need. So B squared minus 4AC, this is 20 squared minus 4 times 25 times 4, right? So what's 20 squared? That's 400, right? And then 4 times 25, that's 100, times 4, is 400. So we get 400 minus 400, that's a 0, yes? So x formula is negative b plus or minus square root of b squared minus 4ac over 2a. Put it in. So our b is 20, so it will be negative 20 plus or minus square root of 0 over 2 times 25. So, square root of 0, that's just 0. So that means that this part right here is gone. So we end up with negative 20 over 2 times 25. Simplify this. And then 5. So we get negative 2 over 5. Yes? Okay? Questions? All right, so let's make a little observation here. First of all, notice that when you solve a quadratic equation, three things could happen, right? You could get real solutions, and you can get two of those distinct, right? So here we have two distinct real solutions, one positive and one with the plus and one with the negative. Yes? So two distinct real solutions. It could also be that the two solutions that you get are actually complex numbers, so no real solutions, and then all of them are complex. Yes? Another situation. And also it could be that you actually have one real solution, not two distinct real solutions. Okay? Who do you think is responsible for all of this? For all of this behavior? In the formula, what quantity do you think is responsible for this? So, for example, why are we getting complex numbers to begin with as a solution?
When 4ac is greater than b squared.
Exactly. In other words, when this quantity here is a negative number, right? That means that we're going to be doing the square root of a negative number, so the I is popping up. Yes? So this quantity is the one responsible for the complex solution. In particular, when this is a negative number, as you can see in here, you already know that you are expecting complex numbers as solutions. Okay? See here. Again, how do you know beforehand that you're going to obtain two distinct real solutions? Once again, this quantity is the key. Because if this happens to be a positive number, like in this case, right? If this is a positive number, then what can you say? Well, this is a positive number, so you're going to get a real number. There is no I popping up. And there will be two possibilities, one with the plus and one with the minus, because this expression will survive. Do you understand? You have square root of something. Like in this case, it was square root of 21. Yes? So, when this is a positive number, you know you're going to have two distinct real solutions. When this is a negative number, you know that you're going to have what type of solution? Complex solutions. The other situation will be, so we already analyzed positive, negative. What's the other case? Zero, right? So what happens when this guy is zero? If this is zero, then this term is not here, and you will only have one solution, namely negative b over 2a. Do you understand this? And you can see it in this case, right? Here it was 0, and then we only have one solution, okay? Which is negative 20 over 25, which simplifies over 50, which simplifies as negative 2 over 5, okay? So because of this, this little quantity is important enough that we give it a name. This is called the discriminant of the equation, okay? We call this the discriminant, and the calculation of the discriminant allows you to tell beforehand what to expect in the equation, okay? Let's say that you're looking for real numbers, for real solutions. Well, instead of actually throwing in and solving the whole equation, find the discriminant, and if you get a negative number, then you already know that you don't need to move on because you are expecting complex right away, okay? And the discriminant, the analysis of the discriminant is going to tell us something about the graph of the function later on, okay? So let me define that. So note the quantity b squared minus 4ac in the formula is called the discriminant. Okay, it's a definition. It's called the discriminant. And then typically we, I'm going to denote it by capital D, but in some places you will see the letter delta, like a triangle like this. This is a Greek symbol, and this stands for capital D in Greek. Okay? The lowercase d is also called delta, and something along these lines. Okay? Anyway, they're just going to be using D. But if you read other books, you may see the little triangle showing up. Anyway, so D will represent b squared minus 4ac, and that's the discriminant. Okay? So the quadratic formula now has a more friendly form. So quadratic formula and now be written as x equals negative b plus or minus the square root of the discriminant over 2a. Okay? With the understanding that by this d, what I mean is the expression b squared minus 4ac. Okay? So that's why I was finding that expression beforehand, because it's good practice when you're going to find it in the formula, when you're going to use the formula. Anyways, you have to calculate this number, right? To have it inside the square root. So might as well find it first. You look at it and you already know what to expect, and then you proceed if you have. Okay? So I guess a little theorem, and this is, the character of solutions. So consider the quadratic equation a squared plus bx plus c equals 0, with a different than 0, of course, and let d be the discriminant, which is b squared minus 4ac. Then, three things can happen. First one is d could be greater than 0. Second one is d could be equal to 0. And the other possibility is that d is less than 0. And in each of these cases, we can say something about the solution, right? So let's see, in the first case, what can we say?
There's multiple solutions.
Two
solutions?
In 3, there are also 2 solutions, in possibility 3. So be more
Two real
specific.
solutions.
2 real solutions, right? Then the equation has 2 distinct real solutions, right? If the discriminant is equal to 0, what can we say?
There's one real solution.
And the equation has 1 real solution. And in this case, we say that we count it twice, so we say it's a double solution, okay? Because that's a situation when you have a perfect square, actually. And in the last one,
To imagine.
complex, right? Remember, imaginary is just with the I, but complex is the whole thing, right? So then the equation has, if the discriminant is negative, then the equation has 2 complex solutions. And what else can we say about these solutions? Let us take a look at the formula really quick. So the complex part comes from here, right? If d is a negative number, the I is going to pop up in here, but then the real part will always be negative b over 2a, yes? So then the only difference is between the 2 complex numbers is that one is with a positive, another one is with a negative. What does that mean? So a positive, this is the imaginary part, right? Negative d over 2a, that will be the imaginary part. But then one will be positive, the other one will be negative. What does that mean? There will be conjugate pairs, right? So this immediately tells you that not only you get 2 complex solutions, but they are conjugate to each other, okay? So it has 2 complex solutions that are conjugate pairs. So if you immediately, if you know for some reason that 1 minus I is a solution, for free you're gonna get that 1 plus I has to be a solution as well, okay? Because of this. All right, so this will allow you to detect what type of solutions you are going to have before actually solving. Sometimes that's all you care about. You don't even need to solve. If you're interested in the type of solution, just compute this little number and then it will tell you. Okay? All right, questions? No? Okay, good. Let's see, do I want to say something else in here? Yes. As an application, I promised that I would tell you when we started talking about factoring, I told you, that once we learn this, you will know how to figure out whether a polynomial is prime or not. Because when you have weird numbers, like big numbers, so give you a little application. Decide if I don't know, let's say 273x squared plus 571x plus 1343 is prime or not. In other words, let's say I give you this polynomial. Can you factor it? Okay? The way that we have been doing this is, well, let's sit there and try to see if you can, AC, multiply these two guys. In this case, you're going to get a huge number. And then sit there and try to see if you can find two numbers whose product is that big number and the sum is this middle one, right? And let me actually even make it something given. Let's put a 2 here. So we will have multiple possibilities, maybe. So the point is that, if when the numbers are small, that's okay. You can actually exhaust all possibilities. And if none of those work, then you can say, okay, this cannot be done, it's prime. Like in the case of x squared plus x plus 1. We quickly can see that there is no way to find two numbers whose product is 1 and the sum is 1. Okay? And then you make your conclusion immediately. But in here, technically, you need to exhaust all possibilities. How do you know that you look hard enough? How do you know that you check all possible pairs? Okay. So, is there a way to decide this can be done or not? The answer is yes. And the secret is right here in this guy, the discriminant. So let's observe the formula a little bit more. First of all, to factor a polynomial, okay, and this is always over the rationals, right? So in other words, to factor this would mean that I want to be able to write this in the form ax plus b times cx plus d, where a, b, c, d are integers. Okay? That's what it means to be able to factor this nicely, right? In general, you can always factor it, but then you may have radicals, right? Square roots and weird stuff going on. Like, for example, let me give you a silly case here. How do you factor x squared minus 5? How do you factor this? If this is the question that I'm asking you, under this situation, we will say this is prime, okay? Because you cannot write this in this form with a, b, c, or d integers. However, you can factor this. If what you want is to factor, you can factor this as x plus square root of 5 times x minus square root of 5, right? Because you can think of this as square root of 5 squared, and this is a difference of squares. But we're no longer using rational or integers in here, okay? So when I ask you whether something is prime or not, what I'm asking you is, can you factor it like this with a, b, c, d integers, okay? So no weird radicals, nothing like that. So notice that to ask this question, so I'm taking things a little bit further now. To answer this question is equivalent to require what? What type of solutions are you going to obtain? Imagine that you could factor this, okay? You could factor this. What would be the solutions? So what would be the zeros here in this case? X equals what? What are the zeros? Negative b over a. And what's the other possibility?
Negative d over c.
Negative d over c. So to say that we can factor it like this is equivalent to say that we can have this type of zeros, right? What numbers are this? What type of numbers are this? These are rational numbers. So in other words, to be able to factor a polynomial like this is equivalent to say, does it have rational zeros? Or in other words, if you set this equal to 0, we have rational solutions, okay? If you want to have rational solutions, let's come back to the equation. This is the quadratic formula, right? If you want to have rational solutions, what must happen? Rational solutions don't admit square roots in them, right? So what must happen? That when you use your formula, this square root is gone, right? Because if the square root survives, then you're not going to have rational solutions. So what will make the square root be gone?
If it's a perfect square.
Very good. So if your discriminant is a perfect square, it will cancel the square root, and you're going to have rational solutions. Therefore, there's something quickly that you can check. Whenever you want to determine if a polynomial is prime or not, compute the discriminant. If you get a perfect square, it can be factored, so it's not prime. If it's not a perfect square, it is prime. Do you understand what I'm saying? So, to answer the question, So I guess let me say here remark a polynomial a squared plus bx plus c can be factored with integer coefficients if and only if, this means if and only if, okay? Mathematical related. So if and only if the discriminant, which is b squared minus 4ac, is a perfect square. Okay, so to decide whether you can factor or not, look at this number. So let's go back to our example here. Let's see, 273x squared plus 571x plus 1,342. Okay, I'm gonna calculate my discriminant. So that's gonna be 571 squared minus 4 times 273 times 1,342. What is this? I mean, hopefully, I don't want to get something negative because then, so, but okay. And by the way, if we get something negative also, even if it's a perfect square, but if the discriminant is negative, it's also prime, right? Because even more, the roots are not going to be rational, they're going to be complex, okay? So I guess when I say this is a perfect square, let me say here, I'm positive. Okay, so let's see, 571 squared, this number, then minus 4 times 273 times 1,342. Okay, I get a negative number, so so that means prime. Okay, let's adapt it a little bit more. So let's do 273x squared plus 50x, and then let's say, I don't know, minus. Actually, if I put a minus here, that will solve my issue. So let me put a minus here. That way I don't have to do a new example. But anyways, you know, it's just the other one is. So if I put a minus in there, this will be a minus here, making this a plus, okay? But once again, if it's negative, you automatically get that it's prime, but you know, that's like kind of trivial. So 571 squared, then that will be plus 4 times 273 times 1,342. Okay, so here I'm getting 1791,505. So this is the discriminant, and then how do you check whether this is a perfect square or not? The quickest way is figure a square root of. If you don't get an integer in here, then it's not a perfect square. Okay? And it's not a perfect square. So this guy here is not a perfect square. So this guy is prime. Okay? So that's one way that you can use whenever you are unsure whether you can factor a polynomial or not. Do this. Okay? Find the discriminant and it will tell you. That's a quick application of that. All right. Questions? Yes? No? Okay, good. So now we know how to solve any quadratic equation. Okay?